Welcome to This Explainer. Okay, if you've ever watched an AI project just completely spiral out of control, you definitely know the pain. Today, we're diving deep into exactly how we plan and build products in the age of artificial intelligence. We're looking at the AI Product Requirements Document, the PRD. Look, if you want to build successful AI products, this spec, it's your ultimate alignment, commitment, and memory artifact. It literally forces everyone across the board to agree before a single line of code is even written.
Okay, let's dive into this with a perfect quote from Joel Spolsky. The act of writing a spec is more valuable than the spec itself. Writing forces clarity. You simply cannot write a precise specification for a vague idea. When you transition into AI product development, writing out the spec reveals exactly where your thinking is, well, kind of muddy. If you just tell your engineering team, hey, make it smart, instead of defining exact parameters, they're going to translate that muddy thinking directly into unpredictable code, and nobody wants that.
So here is our blueprint for today. First, we'll cover the foundation, traditional versus AI specs. Second, the AI spec template. Third, the confidence contract. Fourth, some real-world case studies. And finally, number 5, common mistakes. Section 1, foundation, traditional versus AI specs. To start off, we really need to understand our first foundational shift. AI completely shatters the old rules of traditional software development, and your product documentation needs to reflect that new reality immediately. This is the absolute core mental pivot you have to make, shifting from deterministic to probabilistic planning. Think about it. Traditional specs describe deterministic behavior. If the user does X, the system does Y. Boom, simple. But AI product specs, they have to describe probabilistic behavior. It's like a giant puzzle. Take a transcription feature, for example. For the exact same audio input, an AI system might transcribe it perfectly 80% of the time, struggle with an accent 15% of the time, and just fail entirely 5% of the time. Your spec must rigorously account for every single one of those scenarios before the building phase even begins. Now, because of this whole probabilistic nature, literally every section of a traditional PRD needs a major overhaul. Take error states, for example. In traditional software, this is a pretty small list, right? Just network timeouts or simple system errors. But in AI, this transforms into a massive failure mode taxonomy. We're talking wrong outputs, hallucinations, biased expressions, the whole shebang. Success metrics have to expand too. You aren't just looking at basic adoption rates anymore. You must explicitly define inference costs per user, latency percentiles, and, this is huge, explicit caps on hallucination rates. That means setting the absolute maximum number of times the AI is allowed to confidently make things up before we literally pull the plug.
Section 2, the blueprint, AI spec template breakdown. Let's move to and see how this builds with a practical anchor example. Imagine a hypothetical yet highly complex AI meeting intelligence product. It's designed to listen to meetings and extract decisions and action items. Right off the bat, in the problem statement of your AI spec, you absolutely must include a why AI field. This is critical to prevent technology-first thinking. You have to force the team to prove exactly why simpler algorithms or just human workflows can't solve the core user problem. In our meeting intelligence example, a rule-based system completely fails because real meeting language is incredibly informal. Saying, let's have Sarah loop back on pricing is only an action item if you actually have the context. Only semantic large language models can reliably extract true commitments from that kind of informal chatter. Now, what's really interesting about this slide is how we define model quality metrics. You cannot just casually say, oh, make it accurate. No way. You need exact pass/fail criteria. For our meeting product, we might set an 85% summary completeness threshold measured against human evaluators alongside a strict 45-second P95 latency service level agreement. These exact numbers dictate whether a model actually ships. If it only hits 80%, it does not go to production, period, no matter how gorgeous the user interface happens to be. Next up is the failure mode taxonomy. You have to anticipate distinct failures before engineering begins. This protects long-term user trust. If the AI hallucinates an action item that literally never happened in the meeting, that's a high-severity failure. So your spec dictates we need a specific one-tap remove button right there in the UX. If the summary is low confidence because of, say, bad audio, that's medium severity. Here, the spec dictates we display a partial summary with an explicit warning caveat, rather than pretending it's totally perfect. And then we have the data flywheel. Listen, this is a competitive moat you build from day one.
Every single time a user clicks that remove button on a hallucinated action item or maybe edits a speaker's name, that correction is logged. It's then converted directly into a training signal for monthly fine-tuning. This creates an incredible loop. More usage leads to more corrections, which leads to a better model and ultimately a higher acceptance rate. Your product literally gets smarter every single time someone uses it. But here's the catch. You spec this out immediately. You do not just bolt it on later. Your rollout plan also changes drastically. You need strict evaluation gates. Week 0 is offline evaluation on a benchmark of 500 meetings. Then, in weeks 1 and 2, you might do a 5% shadow rollout really just to monitor if users are opting out. In weeks 3 and 4, you push to 25% to test for latency. Crucially, your spec must include rollback triggers for that final 100% rollout. For instance, if the user correction rate exceeds 35% in live production, an automatic 4-hour rollback to the previous model version is instantly triggered.
Finally, the blueprint demands an explicit out-of-scope section. You have to clearly define what the model is not expected to handle. If it can't handle meetings with heavy background noise or really dense medical jargon, say so right in the spec. Providing specific UX fallbacks for those scenarios, like maybe prompting the user to take manual notes, prevents the model from operating dangerously below the trust threshold. It's not a failure to limit your scope, it's just responsible product design.
Section 3. The confidence contract. So the crucial point is this brings us to the single most neglected section in AI product specifications. But honestly, it's the section that ultimately dictates user trust calibration. Overconfident AI errors are literally the most damaging trust failures possible. If an AI is wrong, but it sounds incredibly confident about it, the user might take a consequential action based on bad data. And guess what? They will never trust your product again. The confidence and uncertainty communication contract is your defense here. It defines exactly how the product expresses its internal confidence levels to the user.
The contract maps out 4 distinct states. First, high confidence. This means the output is clean, with absolutely no hedging language. Second, medium confidence. The product displays the output, but it's paired with a gentle verification prompt, signaling users to just double-check things. Third, low confidence. Here, there's an explicit warning stating, "I'm not confident about this, please verify." And fourth, cannot produce. This is where the model honestly states it cannot do the task and offers a clear alternative. By defining these states up front, users intuitively learn to seamlessly trust confident outputs, while appropriately pausing to verify the uncertain ones.
Section 4. Real-world case studies. And this brilliantly illustrates what a mature spec looks like in the wild. Let's look at Otter.ai. When Otter isn't totally sure who's talking, it labels them unknown speaker. That is a low-confidence state specified directly in their taxonomy. When there are way too many people in a meeting, they label the summary as a beta feature. That's their out-of-scope handling. And their inline transcript editing, that's the data flywheel in action. These features didn't just happen by accident. They were architected in the spec way before a single line of code was written.
On the flip side, let's look at the early days of Microsoft 365 Copilot. Users reported that it confidently cited emails they really didn't expect it to access, which caused some intense privacy anxiety. Copilot also frequently pulled in names from completely unrelated documents. Now, these types of enterprise AI product failures are almost always traceable to rushed or incomplete data requirements sections. The PRD either completely missed the confidence contract, failed to spec out strict source attribution, or just lacked clear retrieval failure modes.
Section 5. Avoiding common mistakes.
All right, let's wrap up this explainer with some structural warnings. Here are the 7 deadly spec failures every product manager and tech leader absolutely must avoid. 1. Mapping only the happy paths and totally ignoring complex errors. 2. Undefined measurement methodologies. Look, saying 90% accurate means absolutely nothing if you don't define exactly how you test it. 3. Omitting the why AI defense. 4. Treating privacy merely as a legal checkbox rather than a core product constraint. 5. Lacking clear rollback procedures when model updates degrade performance. 6. Using deterministic language. Stating the system will extract all items is deterministically false, and it sets your entire engineering team up for failure. And finally, 7. Missing the data flywheel, effectively dooming your product to never improve beyond its launch day.
I want to leave you with a crucial question to really reflect on. Take this mastery checklist back to your own desks and audit your current projects. Rigorous, probabilistic planning is the only way to build products that earn and keep user trust.
So ask yourself, are your AI product specifications designing for continuous improvement, or are they setting you up for silent trust failures in production? Thanks for hanging out with me on this explainer. Catch you next time.